Howdy, y'all. It is great to be here. Super thrilled to be speaking for y'all here at AxeCon, and I hope that you've been enjoying the talks. They have been phenomenal so far. I can only hope to contribute to that. Yeah, so I will be presenting Hijacking Screenreaders with CSS. This is one of my favorite talks to give. I enjoy it a lot, and I hope you do as well. Like Joshua said, so there are going to be some demos, and I hope that you share your reactions to those demos in the chat. If you're feeling surprised or shocked or delighted or outraged or nauseous or whatever, just feel free to put that in the chat. Let me know what you're thinking. Because this is so demo heavy, I wanted to make sure that y'all had a chance to explore the demos for yourself in whatever format is easiest for you. So I have put up a landing page at benmyers.dev/AxeCon. If you go there, you'll find the code snippets, you'll find the videos that I'm going to play, and you'll find links to hosted web pages that show each of these examples so that you can play with them yourselves. Additionally, there's a section of resources at the end too that just further the things that I'm talking about today. So I'll give you all a chance to go there if you find that that would be helpful for your experience of this presentation. In the meantime, I'll go ahead and introduce myself. My name is Ben. I am a front-end developer at Microsoft. I work on the Microsoft Learn developer documentation platform, though today I'm just representing myself. I like to blog about accessibility, and I host a stream called Some Antics, where I bring on guests from around web development and web design to teach me something about building user experiences for the web in a hands-on way with a focus on accessibility. And you can find that at twitch.tv/someanticsdev. Yeah, so that's a bit about me. That's how you can access the resources for today's presentation. We're going to be doing several things, so I want to kind of signpost the roadmap for today. This talk is about a lot of things. It is nominally about CSS and screen readers, but it's also a bit about mental models, and it's about history, and it's about our role in the future of web development. So there's going to be kind of three parts to this whole presentation. First of all, I want to bend your brain. I want to introduce you to some mental models that I started out with when I was learning web development. And I'm going to show you the examples that just blew those mental models to smithereens. After that, we're going to dive deeper. We're going to understand where these demos are coming from, how these come about, why they are the way they are. This is going to be an odyssey through history and through technology and through really how modern day assistive technologies work. And then after that, we're going to draw some larger lessons learned, life lessons that we can take away. So these are the three parts of today's presentation. So first of all, I know that everyone kind of has their own journey through the web, their own journey learning how to develop web experiences. When I started, one of the first things that was drilled into my head was this idea of the separation of content and presentation, right? You've got your HTML, and the HTML is your content. It's the structure, it's the semantics, it's the meaning of things. And then there's your presentation. There's your CSS, the aesthetics, the design of it, right? What makes this site aesthetically yours and not just some other site, you know? So we've got these kind of twin ideas of content and presentation, HTML and CSS, and never the twain shall meet, right? I imagine a lot of us have had kind of this philosophy, this dogma, this mental model, right? Early on in my career, I started learning about accessibility. I started playing around with screen readers and magnifiers and other forms of assistive technologies. I wanted to build user experiences that were accessible for disabled people such as myself. And as I was playing around with screen readers, I kind of started to build this other mental model, which is that screen readers, they're purely semantics, right? They care. Screen readers care whether you've used a button in the markup, right? They know. Screen readers are purely content, right? So I had this kind of joint mental model that I'll share with y'all that I imagine many of us have felt, even if we haven't quite articulated this conclusion. So CSS isn't content, right? And we know that screen readers, they care about content. They care about semantics. They care about structure. And so I had assumed, as we'll see naively, that screen readers don't care about our CSS. Screen readers exist in the platonic raw land of semantics and markup and not CSS. And so this was kind of this mental model that I had, this assumption that I made. And I saw a few examples that really challenge those, and I'll share those with you. We're going to start fairly familiar and normal, and then we're just going to get weirder from there. So let's start with the example that most of us have probably seen at this point. On the left here, I have some markup for 3 paragraphs. The middle paragraph has the display none property, and this ensures that the paragraph does not show up at all on the web page. You cannot see it. You can't copy paste it, nothing, right? It effectively does not exist. Now, if CSS didn't impact screen readers at all, if screen readers didn't care about our CSS, then we would still expect the screen reader to go ahead and announce that middle paragraph. But as I'm about to show, that's not what happens.
I'll be read aloud. I will also be read aloud.
So that was VoiceOver. It announced the first paragraph. It announced the third paragraph. It completely skipped over the middle paragraph, which was the one that was hidden with display none. This is a fairly familiar scenario. Display none, visibility hidden, setting the width and height of an element to 0. These are all ways to exclude content from screen reader output. This is why you get the famous or perhaps infamous or notorious SR only utility class, also called visually hidden, and it's had a bunch of other names throughout history, as sort of a bundle of hacks that we use to hide content visually, but still leave it exposed for assistive technologies like screen readers. So this is kind of the first case in point that something about the CSS we're writing is impacting something about the way screen readers are announcing our page. But let's keep going. In this case, I have some markup for a button that says edit, and I have some CSS styles that add a before pseudo element to that button, adding a little pencil emoji. Pseudo elements, by their very nature, don't exist in the DOM. If we had this mental model that screen readers were purely just parsing and announcing the DOM, then there is no way a screen reader would know that this pencil emoji is there, right? This pencil does not exist in the DOM. It is purely an addition by way of CSS. And yet, when VoiceOver announces the button, what do we hear?
You pencil, edit, button.
In case you missed that, it was pencil, edit, button. So VoiceOver, in this case, is announcing the pencil button, or sorry, the pencil icon, that pencil emoji there. I should clarify that even though I've used VoiceOver for this demo and the past one, this behavior should be consistent across all major browsers and all major screen readers. So just good to know. We have officially used CSS to invent new content, which shouldn't be doable, right? We can remove content, we can add content. This is a little challenging for this notion of separation of content and presentation, this kind of clear demarcation between HTML and CSS and what screen readers care about. But let's keep going. On the left, I've got the markup for a button that says add. And before we go any further, I want to just show you real quickly how that sounds to a screen reader.
Add button.
Pretty intuitively, the screen reader, VoiceOver in this case, just says add button. This is what we would expect. But we can get a little weirder with this. Let's say, you know, the design changes and we need this button to become a little more prominent. And the suggestion is perhaps to make the entire button uppercase, right? Surely that can't go wrong, right? And we're following web dev best practices. So we're going to use some CSS for this. We're going to apply the text transform uppercase style to our button. And as you can see on the right, we have this button with a all uppercase add. Now, this is all in CSS. We haven't changed the underlying markup. The text, as far as the DOM element is concerned, is the same. In theory, the screen reader should announce this the same way, right? Assuming screen readers don't care about our CSS. And yet, And this, I want to call out this behavior. I'm specifically calling out voiceover here. This is going to be a voiceover thing.
ADD button.
If you missed that, voiceover said ADD button. Now this is a bit odd, right? We changed with CSS, we changed how this button was capitalized, and now voiceover pronounced it completely differently. It spelled it out. I should clarify, not every word that's uppercase is going to be announced as an acronym, but in this case, voiceover is actually tripped up because it's receiving capital A, capital D, and it doesn't know whether that's an uppercase add or whether it's, say, short for attention deficit disorder or some other acronym of the sort. I've also seen, I used to work at a place that had an all caps log on button, and voiceover would consistently pronounce that LOG on, which I found bizarre. But yeah, we can change the pronunciation of words with capitalization via CSS. This is funky. I'm not gonna lie. It's odd, right? But we can get a little weirder. This is very, very specifically a WebKit thing. So I'm going to be demonstrating this with VoiceOver and WebKit. On the left, I'm demonstrating it's truncated, but I've got the simple markup for an unordered list. On the right, I'm displaying an unordered list with 4 items: apples, bananas, cherries, and dragon fruits. I haven't done anything to influence the list styles, so it's just using the default styles. And we're going to hear real quickly how VoiceOver decides to handle this list.
List 4 items. Bullet, apples, 1 of 4. Bullet, bananas, 2 of 4. Bullet, cherries, 3 of 4. Bullet, dragon fruits, 4 of 4. End of list.
Okay, so when VoiceOver got to this list, it told the user that this was a list. It told the user how many items were in the list. It let the user navigate item by item, and for every one, it said bullet, and then the list item, and then the placement in the list. And then at the end, it said that it was the end of the list. You're exiting the list. Screen readers can also allow users to treat the list as like one block that they could skip over if they wanted to. So all of that is kind of implied by these unordered list semantics. But in WebKit, when you remove the bullets, let's say this is the golden age of minimalism, right? Our design would rather we not have those bullets. Those are ugly. They're so 2000s or whatever. We can remove the bullets with list style none applied to the unordered list. And being the dutiful accessibility testers that we are, let's just test this again. It shouldn't change, right? Nothing about the markup has changed. The semantics should still be there, right? But let's see what happens now.
Apples, bananas, cherries, dragon fruits.
By removing the list style, this list forgot to be a list. The user is no longer told that this is a list. They're no longer able to skip the list as like one whole entity. And the user is forced to navigate through each of these items one by one, and each of them is treated as no more than a div. So this list forgot to be a list once we remove those bullets. Again, I should clarify, that is very specifically a WebKit thing. So you're only going to get that with VoiceOver and a WebKit browser like Safari. So I have one more example for you. And this example is going to be, I think, the weirdest by far. So on the left, we have, again, there's some truncation going on, but we have the markup for a table. And this markup, we're going to use minimal semantics for. We've got the table element. We've got a series of TR elements for rows. Each of those will have some TDs for each of the cells. We're not making full use of the table semantics that we could. We aren't using the caption element. We're not using TH header cells. We're not using T-foot or T-body, T-head, any of those, right? It is purely a table with a bunch of rows with a bunch of cells. And on the right, we have an example table that lists the 10 most populous countries. And this is, I'm demonstrating this in Chrome. You'll actually find similar behaviors for this across every major browser and every major screen reader. Let's see how the screen reader tackles this table.
Rank, country, population, percent of world, date, source, official or UN, 1, China.
Okay, so again, the user wasn't actually told anything about the fact that this was a table. They weren't told things that they might expect to hear, like how many columns or rows there were. And they're forced to go through each element linearly. Start at the top left, go right, go to the second row, go right, and so forth, right? This is not actually the expected screen reader experience for a table. If you're using the fully fledged table semantics, the screen reader user would expect to be told how many rows and columns there are, and they'd be able to navigate through the table in all four directions. They could go up, they could go down, left, right, and so forth. But something about this table that we've got here is broken. It is treating, basically, this table is treating every cell as a bunch of divs. But we can fix this. We have the technology. We can do weird stuff. We're doing some mad science here today. So what I'm going to do is I'm going to zebra stripe the table naturally. And the way I'm doing this is with a CSS style for tr:(nth child even, and we're applying a background color. And we let's just hear the difference.
You are currently on a table inside of web content. To navigate the cells within this table, press Control Option and then up arrow, down arrow, left arrow, or right arrow. Rank, column 1 of 6. Country, column 2 of 6, row 2 of 11. China, row 3 of 11. India.
Okay, so by zebra striping our table, we were able to restore table semantics to a table that didn't have them. You don't have to zebra stripe. You could also use borders. You could also just have a whole bunch of rows and columns and stuff like that. And ideally, you should be using table semantics. Like that's the real underlying fix here, right? Use table semantics. But it is a little bizarre that doing something like zebra striping our table could somehow restore table semantics that had been stripped away. I find this just absolutely mind-boggling. This is weird. If you're like me, you probably have a series of questions, right? Wait a second. Do screen readers read CSS? Oh God, do they read all of my CSS? Why? Semantics are dead to me now. Now, that's not so much a question so much as a thought, but it felt relevant, so I've included it anyways. And oftentimes when I present this, a question that people ask me is, what are screen readers doing wrong? There's this kind of implicit assumption here that the screen readers are just super buggy, right? They've got so many bugs, and it's just bizarre that CSS would cause some sort of fault to trip inside of a screen reader, right? And so I want to kind of walk through and talk through how this is actually happening, what the mechanics are that led to this behavior, because as we're going to see, all of this is actually very intentional. So let's dive into part 2. We're going to dive deeper. And to do this, we're actually going to need a visit from the ghost of screen readers past. So the first screen readers were actually built for DOS computers. You know the ones. They were all terminals, nothing else, right? Purely text-based. And it was discovered that you could send the computer's text buffer to a speech synthesis chip. And you could have effectively whatever was under the cursor be announced aloud. But then came this new trend. Largely we can blame Apple for this. It's called the Graphical User Interface, or GUI. No worries, it'll never catch on. But it presented a new problem. How do you expose, in this world of like 2 dimensions and windows and graphics and gizmos and all that jazz, how do you now expose that to people who can't see? And so the first screen reader to really tackle GUI interfaces was Berkeley Outspoken. I'm showing here actually like the main menu for Berkeley Outspoken. And this used a fascinating technique. The way it worked was it intercepted the computer's low-level graphics instructions, and then it guessed. So it would say, oh, you're printing some text here, and you're painting a little rectangle around it. I think that's a button. Oh, you've got a circle with some text to the right. That's probably a radio. And so it would guess, and then as the GUI changed, basically it would kind of keep track of everything it had assumed about the operating system. and kind of add in new changes as it went. And if you're at all, if your eyes are going wide with shock and horror as you're thinking of like all the ways that that could go wrong, it did, right? The system had no way of picking up on new controls, new interfaces, and also issues like incorrect assumptions about the interface tended to snowball as people continued to use the application. And so it was the best we had for a good long while, but it wasn't really tenable as a solution. There was efforts in the vein of like doing something kind of similar with DOMs, with web pages, because you wouldn't actually need to scrape low-level graphics instructions. You could just kind of parse the DOM itself and try to interpret that. But this itself led to issues too with when HTML5 came out and introduced a bunch of new elements. Screen readers like JAWS took a while to update, and the update was expensive. So if you wanted to be able to use sites that were using the latest, greatest, up-to-datest markup, you probably had to fork over some money, or you had to wait for that stuff to be supported. And so screen readers kind of had this underlying problem here with this approach of like trying to reverse engineer meaning. What we learned as an industry is that reverse engineering meaning is educated guesswork at best. If you're taking any sort of approach as an assistive technology where you're trying to divine, if you're trying to, as an oracle, reverse engineer meaning of an interface of an application after the fact, you're fighting an uphill battle. You're going to lose, right? You can do your best and it might be great, but ultimately we needed to start from somewhere else. We needed to go with the flow of information. And so the approach came in the form of actually the operating system. So what you may not know is that nowadays your operating system exposes a whole like just absolute myriad of low-level primitives to define common UI controls. So you can have an object for like a checkbox, or you could have an object for a button or an image or a combo box, all that kind of stuff. All possible user interface controls are defined as these like low-level primitives that are defined at the operating system level. And that means that every application is speaking the same language. Every application you use is assembling these different low-level primitives into just a compilation that represents the experience of their application. Whether you're using Zoom like I am for this talk, or whether you're using PowerPoint like I am, or whether you're in a browser, right? They're all using the same primitives to define their application. And these primitives are constructed in a form that specifically assistive technologies can understand. And just to demonstrate this, when you go into a browser and there's one of those checkboxes that's like, I agree to the terms and conditions as you sign your life away, that checkbox is, as far as your operating system is concerned, the same kind of thing as the checkboxes that appear in your operating system's native dialogues, or, you know, in your PowerPoint settings dialogues, for instance. They're all the same thing. They're all the same language. And so browsers take all of these different kind of low-level operating system defined primitives and assemble them into a hierarchy that represents the structure of the page. And this is called the accessibility tree. You might have actually seen this before. It turns out that browsers have dev tools that'll let you see what is in the accessibility tree. If you've ever opened up your browser dev tools and gone into the accessibility pane, here I'm demonstrating that I've done this for the AxCon landing page because I enjoy a healthy bit of self-referentialness. If you've ever gone into your dev tools and then gone to the accessibility pane, it's breaking down your web page in terms of these primitives that assistive technologies can understand. So your browser receives a web page. It assembles a DOM, it assembles a document object model that represents the page, but then it also assembles an accessibility tree, this representation of our page in a language that assistive technologies such as screen readers can understand and parse. The screen reader, or sorry, the browser builds this accessibility tree and just hands it off to the operating system. And then your screen reader or other assistive technology will periodically reach out to the operating system and go, hey, what's the active applications accessibility tree? Any updates I should announce? And then it does so. And every time your DOM updates, your web page updates, the browser is going, oh, okay, I need to now pass this back onto the operating system again so that the screen reader can then parse it. And this is constantly happening. It turns out browsers are really good at building trees that represent web pages. Like that is what they do. They are tree making machines. And all of this stuff happens for us behind the scenes. And one of the points I want to hit on here is that browsers don't just make the accessibility tree, they curate it. Browsers have an incredibly influential role here because it turns out some websites suck, right? Some websites haven't been built with accessibility in mind, or some websites are just really legacy, right? They've been out there for a while, they've existed for a while. And that doesn't mean that disabled users should still have a worse experience. Just because developers weren't aware of or weren't able to perform accessibility best practices in their development doesn't mean that disabled users should have a worse experience. And so browsers actually intervene here. They do a lot of really smart things. They take in a lot of heuristics and tweak and curate the accessibility tree in just subtle ways here and there to make the experience more usable in general. And it might have dawned on you now what's happening with our CSS examples, right? Because the browser is reading our CSS and going, oh, well, this CSS is creating this experience for sighted users. That's part of the experience. Let me just curate, tweak, modify the accessibility tree in a certain way to provide a similar experience for people who rely on assistive technologies like screen readers. And so that example of like display none, hiding elements from assistive technology output as well, well, display none has historically been used as a pretty efficient way to hide content from everyone, right? And so browsers have assumed, I believe correctly, that if you apply display none to an element, no one is meant to get to it, right? Not just sighted users, but keyboard users, screen reader users, anyone, right? If you hide content with display none, no one should get to it. And it is as effectively as good as not in the page. And so browsers will take display none and visibility hidden and width and height 0 as cues to just prune that element from the accessibility tree. And the same kind of goes actually in reverse for the pseudo elements. As far as the sighted user goes, that pencil was part of the edit button. That was just part of the experience. That was part of the content. They neither know or care that that pencil was added in via CSS. It wasn't really in the page. To them, it was real. And so browsers go in and they add those pseudo elements to the ways they expose those elements to assistive technologies. And there's just so much intention that goes into this that I think is really, really neat. And I wanted to highlight a couple of other examples, ways in which the weirder examples start to make sense. So you can find code like this in every major browser's engine. So you can find this in Chromium. You can find this in WebKit. Here I'm highlighting Gecko, which is the engine that powers Firefox. This is a really long function called isProbablyLayoutTable. And so, way back when, hopefully far less these days, but it was fairly common to use a table as a way to lay out a page or parts of a page as a grid, even when that content was not actually data that should be arranged in a tabular way. And so you would get this kind of plethora of layout tables. And this experience sucks for screen reader users, right? You get so much extra verbosity that just adds nothing, right? And so browsers stepped in. They all of them have code like this, a big hefty method that takes a table and it tries to guess whether it's being used for layout or for data. And it uses a bunch of heuristics. And those heuristics, I've left a lot of them out of this slide, but those heuristics include things like, well, how many columns and rows are there? Is any aria being applied? Are you using the full range of semantics like T-body or caption or anything like that? But it also uses CSS. Are you using borders? Are you zebra striping? So I've got a little bit of code here. This is within a loop. This is within a loop that does if child index is greater than 0, so if this isn't the first row, and the previous row had a different color from this, then we're going to say, no, this isn't a layout table. This is probably a data table. All browsers have code like this. And they're specifically trying to combat the scourge of layout tables and make sure that just because a website used a layout table doesn't mean it has to suck for real disabled people. Similarly, let's go back to that WebKit example of no more list semantics when you remove list bullets. There is a wonderful thread from James Craig on the WebKit team where he goes into, it's a 20 tweet thread, and I'm only highlighting 2 here. The whole thread, he talks about WebKit's rationale. I'll read 2 tweets here. The first says, I reviewed lots of emails, bug reports, and feedback from voiceover users at the time. He's referring to a time where WebKit started exposing, or voiceover rather, started exposing lists more. Voiceover users at the time, about 2014, that said things like the web has too many lists, or all I hear when reading news sites is list 2 items, end of list 4 items, and I don't care about all the lists. Later in the thread, he said, the list heuristics to determine role relevance are more complicated than most web authors assume, but in general, the principle is this. If all of the styles that make it list-like have been removed, it's no longer relevant to convey it as a list. So the gist of this here is that voiceover users provided feedback to voiceover and WebKit that said the web is full of too many lists. It's too noisy. And the WebKit team made the executive decision to say, okay, well, if you make it look not like a list, it's not a list. We're not going to expose it as a list. And so they actually stripped those semantics. Now, I should add, since the first time I've given this talk, this is actually a very recent change. If you stick that list, even if you remove the list styles, if you stick the list in a navigation, list semantics will be restored now. So this is a new change here. But yeah, this is an example of the priority of constituencies at play. Here, people realize that a better user experience for at least one demographic was to say, if you don't make things a list visually, it shouldn't be a list semantically as well. And so all of this was done with intention, which I think is really neat. It actually speaks to some larger takeaways here. So let's quickly do part 3. What are our life lessons, the larger takeaways that we can have from this talk? First of all, test early, test often. Test on a wide variety of assistive technologies and browsers and operating systems, because you will have discrepancies like these across different experiences. Just because JAWS exposes that list as a list doesn't mean that VoiceOver does, and vice versa. So test early, test often. You're not sure, you're never sure when the CSS that you write is definitively going to impact screen reader output or other assistive technologies in any way. Test frequently, test profusely. But the second point I have to make is about the concept of a cow path, which is that if you're unfamiliar, this is a path that has never really been paved, but instead folks found it convenient to just like cut through a field in a certain way. And over time that wore down the grass enough to create a path. And there's this phrase called paving the cow paths, which is when you recognize that a cow path has been made, you pave over it, you formalize it, you make it even better to use, even more comfortable to use, because you recognize that people are already finding that the more usable route. And browsers, what they're doing here is they're paving cow paths. Basically, they're taking techniques that you and I, as web developers, are doing every day. Things like, oh, we're efficiently hiding content with display none, or we're abusing the table element to create some layouts. They're taking those and they're formalizing that in some way, creating heuristics around it so that future users' experiences won't be so heavily impacted by the choices we make and the missteps we take. And so, nowadays it can be kind of a joke that people use tables for layout, but browsers still have to support websites that did that, websites that do that, right? Operating systems, screen readers, they still have to work around that. And so I would challenge you to take some time and think through, what are the hacks, the patterns, the things you're doing today in your day-to-day that, someday may still be out there as a legacy pattern that browsers and assistive technologies still have to work around. What are the cowpaths you're creating? What are those patterns? What is going to impact screen reader users and developers, frankly, down the road in this way? So that's been it for this talk. If you would like to follow up, if you'd like to reach out to me, I can be found on Twitter at benmyers. You can find me on Mastodon. I'm on the a11y.info instance as @Ben. And you can also read my blog, benmyers.dev. And yeah, that's what I've got. I suppose I'll hand this over to the Q&A session.
Wonderful. Thank you so much, Ben. That was awesome content. We've had so much interaction in the chat, a lot of people sharing their experiences and some findings with their applications. So I wanted to bring one Q&A topic up. It seems to be pretty popular here. Is there any automated screen reader testing tool that you can suggest?
Ooh, screen reader testing tool. Honestly, with screen reader testing, I think you just have to use a screen reader yourself. I think that I don't know, there's a trend sometimes where developers will do anything in their power to like avoid touching a screen reader, but like in the end, like you have to know how real users are really experiencing a thing. And the only way to do that is to like properly hop into assistive tech and play around with it yourself. In terms of other automated tools, I am a fan of Axe Dev Tools. I hear that people here might be somewhat familiar with that tool, perhaps, but I tend to use that quite heavily. A problem that you'll get when it comes to like the concept of automating these screen reader tests is that the automations don't necessarily know what the expected experience was. When you display none that element, did you really mean to hide it from assistive technology output, or did you intend for it to like be visible or exposed to assistive technology? The problem here, it's the same problem that screen readers had, right? Is you can't reverse engineer intent. That is just inherently impossible. You're always going to be lacking in the context whenever you have some sort of automation that tries to come in after the fact. Communication about this stuff has to flow downstream. And so I'm not personally familiar with automated screen reader testing that would, in my mind, provide the experience you're looking for, I think there.
Yeah, I know there are some capabilities out there. I can post a link to an article I found because it's definitely an interesting topic, and I know, Ben, I'm sure you hear this all the time, and this is something that developers and the accessibility community in general has asked about. But there are limitations there, and just like Ben said, just to reiterate the point, testing and validating as a human is the best way to validate that a web experience is accessible with a screen reader, right? It's almost like cooking a recipe and running some kind of automation to say, is this food good? Well, the only way to really tell is to try it out yourself, right?
100% co-sign there. Yes, absolutely.
Now we will look forward in the future. Maybe our robot overlords will give us the ability to validate sometime. We can't we can't expect that to be ready for us in the near future. So continue using those screen readers.
Yes.
All right. We got another one here. Let's talk about this one from Kai. Kai asks, do you think that a CSS property that works like ARIA hidden attribute might be helpful?
Ooh. This is a bit of a hot button topic. I maybe I would need to see some cases like that, some use cases there. The advantages of doing something like that in CSS is that you can then respond to things like hover and focus events or media queries, right? You get more responsiveness in there, you get more statefulness. However, the downside of that is that if your CSS doesn't load, or if it's overridden by style sheets, user style sheets, for instance, then a lot of that behavior kind of like goes away. You lose that functionality, right? And so if you're expecting to depend on that, yeah, it becomes very tricky, I think. So I would want to see more specific use cases, but for the time being, I'm a little more comfortable with things like ARIA hidden staying in HTML. However, and I did actually recently write a blog post about this. I do feel like things like I mentioned the SR only / visually hidden utility class that some of our attendees may be familiar with. I recently made an article that basically made the case for this should be a native CSS property because it's like purely presentation is what that is. It's about the visual presentation. So I'm still figuring out my own opinions there on those things. But absolutely great question.
Yeah, that's great. And accessibility is a journey, right? We're still figuring it out, and we'll continue doing that in the future. We got another question here from Derek. Will ARIA override those browser decisions and assumptions? For example, in your list demonstration, if you were to add role equal list to the UL element, would it then return to being a list in the accessibility API?
Yes. Yes. You can absolutely, in these cases, you can use role, you can use various ARIA properties to restore the semantics. I'm actually of the opinion, by the way, that in many cases, you probably don't need to restore those semantics, right? Like folks are using WebKit because like that's what they're familiar with. They've picked up experiences from websites and experiences they've had through other sites and applications in the same browser. And I think it's totally fine to if you aren't absolutely sure that this needs to be a list, I think it's totally fine to leave off role equals list. That I think is a bit of a hot button question as well, but that is my personal feeling on that is you don't always need to restore those semantics back in. You can decide that on a case-by-case basis. But yes, role equals list would fix those semantics. In the case of the table where we were using minimal semantics, had you used the full-fledged proper semantics for that, you would have had the table semantics out of the box. I believe role equals table would also have restored those as well. So there are absolutely case-by-case instances where ARIA would kind of band-aid over those browser heuristics again. But you can only do that if you're expecting that, if you're familiar with how the CSS actually impacts how those elements are exposed to assistive technologies.
All right, we got another question here. This one's from Hans. Hans says, nice example with the pencil. How do screen readers behave when you use Unicode from fonts as content in CSS instead of a pencil icon?
Okay, the big old accessibility mantra, it depends, right? This depends a lot on the operating system. It depends on the browser. It depends on the assistive technology you're using, right? So please keep that in mind in everything I say. Massive grain of salt. It depends. It depends on so many factors. But that said, not great. Support for various Unicode characters beyond the characters that you and I might use to write common language day in, day out. Support for that is often not great. There's one of the things you'll see on Twitter sometimes is that people will set their display names to what they think is fonts, but it's really Unicode characters that look like certain presentations of Latin letters. But really, these things are like intended to be like symbols used in mathematics. And so you might spell out Ben with these fancy letters, but what the screen reader user hears is like mathematical letter B, mathematical letter E, mathematical letter N, and so forth. Emojis are I actually debated whether or not I should use an emoji in this example, because this is one of those cases that's very contextual. I think at this point, screen readers typically do announce emojis, but emojis often have very verbose names that often don't actually describe the visual presentation. So if you've ever seen like the red flag emoji, there was a big Twitter meme about that for a while. I think the like official name for that was like upright, uh, like right pointed triangle flag or something like that. No indication that means a red flag. So I wouldn't actually recommend using emojis in the way that I did. I just needed an illustrative example. Make sure if you're doing anything with like emojis and that sort, you're properly marking them as decorative and stuff like that. But just to show that in this case, yeah, it did impact our nice, tidy edit button by renaming it to pencil edit button. That's an experience that's not just going to impact screen reader users, but it'll also impact voice control users, because now some voice control users might be forced to say, click pencil edit button or click pencil edit instead of click edit. So we've actively made their experience worse by not properly handling decorative emojis there. So Unicode support, emoji support, it is flaky. Don't rely on it. But even though it's flaky, like when it does pop in, it's cumbersome, it's verbose, and I still wouldn't recommend, leaving it unhandled in that case. Best to probably avoid it overall.
Yeah, I like that. That's great response. All right, we've got another one here from Angelica. Along with personally using screen readers, what tools or programs would you recommend to a very new designer to begin to recognize the basic qualities of a good accessible design?
Okay, so I recognize I am at AxeCon by DQ Systems, but I am a big fan of Axe DevTools as an automated scanner. It's not the end all be all, because we've mentioned the reasons why automated testing do have limitations. But what I really like about that, especially when you're starting out, is it's going to surface things that you never would have expected, right? It's going to surface things like your root HTML element is missing a lang attribute. When I was starting out, I would run the Axe DevTools scan across a bunch of sites and see what came up. And when I would get something like that lang attribute error, I was like, I don't actually know why this is important. Why is this being flagged? Why is this a problem? And so it gave me something I could Google, right? Something I could look into, further resources to learn more. And I do kind of like that as an iterative approach to learning accessibility, as opposed to drinking from the fire hose. It surfaces things that actively exist on your website. I also would recommend finding resources like the A11Y project has an excellent checklist. If you just Google A11Y project checklist, you should find it. And it goes through a lot of the things that you likely haven't experienced. In general, honestly, try using your page with just your keyboard, right? If things appear missing, if things seem wrong, there's a good chance they are. And so just play around with that. Again, just take the opportunity to experience the web page as similarly as your users as possible. I also recommend following various people on Twitter. Just really anyone in the accessibility community. Many disabled people will share their experience of things. They'll put out videos of like, here's what it's like using this screen reader. And I recommend seeking those out, because nothing beats real lived experience. But yeah, I hope that helps.
Love it. Folks, there have been so many great questions and lots of great chat. We really appreciate you joining this session. We're sorry we can't get to everything, but reach out to Ben. Send Ben an Instagram, connect on LinkedIn, follow on GitHub, get at us on social media everywhere. We'd love to hear. I do want to close with a huge thank you to Ben for sharing this excellent content. Lauren on our tech team, thank you so much. And especially to Beth and Lizzie, thank you for your interpreting on this session. I want to also say thank you to our sponsors, Fable, Walmart, Articulate, Apex, Covantage, and of course, DQ. Everybody, have a great time at AxeCon. We hope to see you again in the next session.
Bye, y'all.